In this question, we're being asked to draw the full structural formulas for each of the following compounds. So for part A, the compound we have is 2,3-dimethyl-but-1-ene. So we want to start off with the parent molecule, the but-1-ene. So but means we have 4 carbons in the longest chain. The ene means that we have a double bond, and that double bond starts on the first carbon. So if I number my carbons, I know the double bond has to start on the first one. So there's my double bond. And the rest I can just always fill in with single bonds. So there's only ever going to be one double bond, and that number tells us where. Then I get onto my branches. So my branches, I have 2 methyl groups. One on the second carbon, one on the third carbon. So I'm going to put a CH3 on the second carbon, that's a methyl group, and another methyl group on the third carbon. So I have all my branches in. I have my parent alkene in. What I need to do now is fill in my bonds with hydrogen. So remember, every carbon has to have 4 bonds. So if I start on the left here with carbon 1, it already has 2 bonds, so I need another 2. And that now has 4 bonds, it's done. Carbon 2 already has 4 bonds coming from it, so I don't need to add any more hydrogens. Carbon 3 has 3 bonds coming out from it, so I need another one for hydrogen. And carbon 4 only has 1 bond coming from it, so I need to add another 3 there for hydrogens. So that's the first one done. That is the full structural formula of 2,3-dimethyl-but-1-ene. On to the next one, 2,4-dimethyl-pent-2-ene. So I'm going to start by drawing the parent alkane here. So 5 carbons, because it's pent. 1, 2, 3, 4, 5. And when I number them, 1, 2, 3, 4, 5, what I should, oh that's not a 4. It ends in ene, which means it's an alkene, so there's a double bond. And that double bond begins on the second carbon. So it begins on the second and goes to the third. And the rest are all single bonds. So that's my parent alkene done. I now need to add my branches in, and I see that I have 2,4-dimethyl. So I have 2 methyl groups, one on the second carbon and one on the fourth carbon. Sorry, something wrong with this pen. So I'll just fix my 4. And then we can go on from there. So that's all the branches done. That's my parent alkene done. Now what I need to do is fill in my hydrogens so that I have 4 bonds on every carbon. So I need to add 3 of them here. On the second carbon, I already have 4 bonds coming from this carbon, so I don't need to add any more hydrogens. On the third carbon, I have 1, 2, 3 bonds coming out, so I'm going to add another hydrogen to make 4. On carbon 4, I have 3 bonds coming out, so I need another one. There's a hydrogen. And on carbon 5, I only had 1 bond coming from it, so I had to add another 3. So that is the full structural formula there of 2,4-dimethyl-pent-2-ene. Now on to part C. So 1,3,5-trimethyl-hex-3-ene. So again, we just begin with the parent alkene. We see that it's hex, which means 1, 2, 3, 4, 5, 6 carbons. And when I number them, I can put in the location of the double bond. Okay, right, sorry, forgot how to count there for a minute. 1, 2, 3, 4, 5, and 6. So there's my 6 carbons, and from the name hex-3-ene, ene means we have a double bond, and it begins on the third carbon. So double bond going there from 3 to 4. The rest of the bonds there I can fill in as single bonds. We'll only ever have 1 double bond. And now onto my branches. So trimethyl, that means I have 3 methyl groups. 1 on the first carbon, 1 on the third carbon, and 1 on the 5th carbon. So a CH3 from the first carbon, a CH3 from the third carbon, and a CH3 from the fifth carbon. Now that all my branches are in, I have my carbon chain done as well with my double bond. I can fill in hydrogens. So just to ensure that every carbon, again, has 4 bonds each. This carbon 3 already has 4 bonds. Carbon 4 already has 3 bonds, so we only need to add one more. Carbon 5 needs 1, and carbon 6 needs 3. So that's my full structural formula for 1,3,5 trimethyl hex 3-ene. On to the last one. So cyclohexene. So we saw before that cyclohexane is an alkane consisting of 6 carbons in a ring. 6 carbons because we have hex, and in a ring because of that cyclo at the beginning. Because we have cyclohex to begin with, we still have 6 carbons in a ring. So 1, 2, 3, 4, 5 and 6. But instead of it ending in ane, it now ends in ene, which means I have a double bond. So I'll put in a double bond. And it doesn't quite matter which bond I do as the double around the ring. Once I put one in, it doesn't really matter because I can count any carbon in this ring as my first carbon. So it doesn't matter. The rest I'm going to put in with single bonds. I have no branches, and you're not going to have branches if this comes up in your exam. So all I need to do now is fill in my hydrogens. So if I start with this carbon here, I need 2 more bonds to make 4. So 2 hydrogens, 2 hydrogens, 2 hydrogens on this one. I need 2 on this one. This carbon here, however, already has 3 bonds, so it only needs 1 more hydrogen. And the carbon at the top already has 3 bonds, so it only needs 1 more hydrogen. So that's the full structural formula for cyclohexene.